In this video, we will practice solving complex trig equations such as these. We're going to need to do some factoring to get this done. And all the while, I need you to have these facts memorized. I'm going to be assuming that you have these facts memorized. Or at least, you should be able to generate this chart within a minute and a half. So, most of the time, we're going to need to have 0 on one side for these types of equations. So keep that in mind. So our first step will be to subtract cotangent x from both sides. So now I have cotangent x cosine squared x minus cotangent x is equal to 0. Notice that I cannot divide both sides by cotangent x to cancel out the cotangents. That is not valid. You can't divide by a trig function on both sides. You can only subtract and add. So now I have this. Notice that we have a common factor of cotangent x. Well, you know what? I left out the 2. All right, notice that we have a common factor of cotangent x. So we're going to pull that GCF, that greatest common factor, out front. That's going to leave behind cosine squared x minus 2 is equal to 0. Then we use good old zero product property. If something times something equals 0, there are two possible solutions. Either the first thing is going to equal 0, that'll give you one solution, or the second thing will equal 0. Either one of these might equal 0. So now we're just going to solve both of these. So what angles will give us a cotangent of 0? Let's take a look at a quick diagram of the unit circle. All right, now keep in mind that this point right here is the point 1, comma 0. This is 0, comma 1. This is negative 1, comma 0. And this is 0, comma negative 1. Now, also keep in mind that cotangent theta on the unit circle, this will be x over y, since tangent is y over x, and this is a reciprocal. So think x over y. So going around this, so if I do x over y, this would be 0 over 1, which equals 0. This would be 1 over 0, which is undefined. Skirt. This is 0 over negative 1, which equals 0. And this is negative 1 over 0, which is undefined. Okay, so we want the cotangent to equal 0, so we see that is happening here and here. All right, the cotangent is in fact 0. So that is pi over 2 and 3 pi over 2. So x is equal to pi over 2 or 3 pi over 2. So those are two solutions so far, but we're not done. We've got to keep going. So solving this sub-equation, I'm going to add 2 to both sides. So that's going to give me cosine squared x is equal to 2. So now I need to take the square root of both sides to unsquare this. So I'm going to take the square root of this, and I'm going to take the square root of that. This would be plus or minus when you take the square root of both sides. All right, so that tells us that the cosine of x would have to equal positive or negative radical 2. Now, what is the square root of 2 as a decimal? I just put the square root of 2 in my calculator, and I'm getting 1.414, etc. All right, so cosine x would be approximately equal to this. So what angle is going to give us a cosine of 1.4 something or negative 1.4 something? Well, the maximum value of cosine is 1, and the minimum value of cosine is negative 1. It doesn't get any bigger or smaller than that. So there is no angle that's going to give us 1.4 or negative 1.4. All right, that's outside the range for cosine. So we won't get any solutions from this side. Okay, the empty set. So we only have two solutions, and they both come from the cotangent side of the equation. So these are the two solutions for problem number 1. Okay, let's take a look at problem number 2. Well, we already have 0 on one side, so that's helpful. So let's go to the step where we look for a common factor. I'm noticing that we have sine x here, and we also have sine x here. So let's factor out that GCF. So if I pull out the sine x, on the inside, that's going to leave 1 minus 2. All right, the sine x is now out here, so that's just going to leave cosine x, and that equals 0. So let us use our 0 product property. So we have sine x equals 0, or 1 minus 2 cosine x equals 0. All right, solving both of these will give us the possible solutions to the original equation. So let's take it one at a time. The sine of what angle or angles will equal 0? Now remember, on the unit circle, the sine is the y value. So looking at our unit circle here, and focusing on the quadrantal angles, the y values are here, 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 and here. We want the sine to be 0. So let's see, I see 0 is going to happen right here and right here. So those are the two angles that have a sine of 0. So that is angle 0 and angle pi. So far that gives me two solutions. So x is equal to 0 or pi. All right, let's see if I get more solutions by solving the other side. So solving this side, I would need to subtract 1 from both sides. So that's going to leave me with negative 2 cosine x is equal to negative 1. Now it's time to divide both sides by negative 2. So those will cancel. A negative divided by a negative is a positive. So I have cosine x is equal to positive 1/2. So the cosine of what angle or angles will give me positive 1/2. Okay, now remember these values that we have memorized. We know that the cosine of pi over 3 is equal to 1/2. Now that is not the one and only solution. That basically gives me the reference angle. Okay, so we now know that the reference angle is pi over 3. So now let's take a closer look at the unit circle, examining this reference angle. So here I have pi. If I split that up 3 ways, then I will have pi over 3. So now I have pi over 3. There are 4 angles with a reference angle of pi over 3. Here, 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 and here. If I take the cosine of any one of these angles, I'm going to get some kind of 1/2. 2 of them will be positive, and 2 of them will be negative 1/2. Cosine is an x value on the unit circle. So these two values on the left, the cosine of these angles will be negative, and the cosine of these angles will be positive. All right, x values are negative to the left and positive to the right. So in this case, we want a positive 1/2. So that means these two angles will be the solutions to this equation. All right, so I'm about to have two solutions. So x is equal to pi over 3 is one of the solutions. But we also have this. So this is 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. Okay, so all together we have 4 solutions to this original equation. All right, looking at problem number 3. At least we have only one type of function. We have, all I see is sine, but we still need to get 0 on one side. So I am going to start by subtracting 2 sine x from both sides. Okay, so that's going to give me sine squared x minus 2 sine x plus 1 is equal to 0. Okay, so this is a trinomial, and when you look at this, you should be thinking of good old polynomials like this: x squared minus 2x plus 1 is equal to 0. Because if we were solving an equation like this, we would factor, and we would say, well, x squared, that's x times x. 1 can only be 1 times 1. Inner plus outer equals middle. Inner I have 1x, outer I have 1x. I'm trying to get negative 2x, so that would only happen if both of these were negative. And then that does give me positive 1, so boom, I factored it. And then I would go on from there. So we have to do the same thing with these trig functions. All right, this can factor just like I just showed you. Okay, sine squared x can only factor as sine x times sine x. 1 can only factor as 1 times 1. Inner plus outer must equal middle. Inner I have 1 sine x. Outer I have 1 sine x. I'm trying to get a middle of negative 2 sine x. That will happen if both of these are negative, which would mean both of these would have to be negative. And a negative times a negative is positive, so that works out. So boom, I factored it. Now we will use the zero product property as we did on the previous couple problems. Now, normally I would set both of these equal to 0 and solve, but they are identical. So there's no point in solving the same equation twice. So I'll just do this one. So if I set sine x minus 1 equal to 0, I would solve this by adding 1 to both sides. So that's going to give me sine x is equal to positive 1. So then I ask myself, sine of what will give me 1? So let's go to the unit circle. Okay, I'm thinking quadrantal angles. All right, multiples of pi over 2. Because here we have 1 comma 0, 0 comma 1, negative 1 comma 0, and 0 comma negative 1. Sine is a y value on the unit circle, so we're looking for y values of 1. Okay, there's 1, and that's it. So there's only one solution to this equation, and it is x is equal to pi over 2. All right, the sine of pi over 2 is 1, and there's no other option. So that is the only solution to this equation. Okay, let's take a look at number 4. Okay, I see all tangent, so that's good. But let's get 0 on one side. So I'm going to go ahead and add 4 to both of these. And I'm going to rewrite this in descending exponential order. So I'm going to put the tangent squared first. So that's going to give me tangent squared theta, and then I'll put the plus 2 tangent theta. I just switched the order. And then negative 3 plus 4 is 1, so I'll put plus 1 is equal to 0. Now, so I've got this trinomial, so just like I did on the previous problem, I'm going to go ahead and try to factor this. Tangent squared theta can only be tangent theta times tangent theta. 1 can only factor as 1 times 1. Now, inner plus outer must equal middle. Inner, I have 1 tangent theta. Outer, I have 1 tangent theta. I'm trying to get a middle of 2 tangent theta. So if I just leave these both positive, that will make 2 tangent theta. And 1 times 1 is 1, so that works out. So here I have factored it. So again, normally I would set both of these equal to 0 and get 2 different solutions. But because these are identical, then I'm not going to solve it twice. So I will just set one of them equal to 0 and solve. So tangent theta plus 1 equals 0. We would solve this by subtracting 1 from both sides. So that's going to give me tangent theta is equal to negative 1. Now the tangent of what angle is equal to negative 1? Actually, forget the negative for a minute. We'll worry about that later. The tangent of what angle is equal to 1? All right, that's something that you should have memorized. The tangent of pi over 4 is equal to 1. That tells us that pi over 4 is the reference angle. Okay, so the reference angle is pi over 4. Now let's go ahead and draw a diagram, take a closer look. All right, since the reference angle is pi over 4, that's what I'm going to draw. So this is pi up here. If I split it in half, now I have pi over 2. If I split that in half, now I have pi over 4. Okay, there are actually 4 angles that have a reference angle of pi over 4. All right, above and below the x-axis. The tangent of any of these angles will give me some kind of a 1. 2 of them will be positive and 2 of them will be negative 1. Tangent is positive in the first and third quadrant. That's something that we have memorized. And tangent is negative in the second and fourth quadrant. So because we want tangent to equal negative 1, that will happen here and here. So these are the 2 solutions to this equation. So in other words, theta will equal, so this is 3 pi over 4. Or, and this would be 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. So these are the 2 solutions to this equation. All right, so that's it for number 4. Okay, let's do one more problem on this video. So take a look at problem number 5. Okay, we already have 0 on one side, and it's already in descending exponential order. So we can go straight to the part where we begin to factor. Okay, 2 sine squared x. That can only factor one way. 2 sine x times sine x. All right, if I multiply those 2 together, I would get 2 sine squared x. 1, I'm ignoring the negative sign for now. 1 can only factor as 1 times 1. So this should be pretty easy. Inner plus outer must equal middle. Inner, I have 1 sine x. Outer, I have 2 sine x. I'm trying to get negative 1 sine x middle. I will get negative 1 if this is a positive 1 sine x and this is a negative 2 sine x. Combining like terms, I would get negative 1. Okay, so that means this would have to be positive to give me the positive 1, and this would have to be negative to give me the negative 2 outer. Also, positive 1 times negative 1 does equal negative 1. So this is correct. So now I have factored it. These are not the same, so I am going to use the zero product property and set both of these equal to 0 and come up with different solutions. So setting the left side equal to 0, 2 sine x plus 1 equals 0. All right, that's going to give me one solution. And setting the right side equal to 0, sine x minus 1 equals 0, all will get a different solution. So let's start by solving the left side. I would subtract 1 from both sides. So that's 2 sine x is equal to negative 1. Then I would divide both sides by 2. These 2's will cancel out. So now I have sine x is equal to negative 1/2. Okay, sine of what angle is equal to negative 1/2? Ignore the negative for a second. The sine of what angle is 1/2? So that's something that we have memorized. Pi over 6. Sine of pi over 6 is 1/2. So that means that pi over 6 is the reference angle here. So let's do a quick sketch. So we have the reference angle is pi over 6. So if I just do a sketch of that, okay, there's pi. Here's pi over 2. And there's pi over 6. So there are 4 angles that have a reference angle of pi over 6. All right, above and below the x-axis. All right, the sine of any of these angles will give me some kind of 1/2, but 2 of them will be positive 1/2 and 2 of them will be negative 1/2. Since sine is a y value on the unit circle, these 2 will be positive and these 2 will be negative. So since I want negative 1/2, then my solutions will be here and here. So those 2 angles are the solutions to this equation. Okay, so that means x is equal to, okay, so pi over 6 is, so this is 6 pi over 6, 7 pi over 6. Or this would be 12 pi over 6, so this must be 11 pi over 6. So these are the 2 solutions to the left equation. All right, so now let's solve the right-hand side of the equation by adding 1 to both sides. So that'll give us sine x is equal to 1. So the sine of what angle will give us 1? This is sounding like a quadrantal angle. So let's just draw a quick diagram to remind us of how this is working. Okay, so we have 1, 0, 0, 1, negative 1, 0, and 0, negative 1. If we want the sine to equal 1, sine is the y value on the unit circle. So I'm looking for y values that are 1. And boom, that's the only one we've got. So that's why the only solution to this equation is going to be x equals pi over 2. Okay, so altogether we have 3 solutions. 7 pi over 6, 11 pi over 6, and pi over 2. Alright, that's going to do it for this video. I will continue with more examples on the next video, so I'll see you there.